Hey y'all, it's Miss Nielsen here to talk to you about problem solving. So when we problem solve, we need to remember our problem solving process. So what are the steps? Well, step one, we want to draw a picture of the situation. That just gives us some context as we move forward. Step two, we want to write down the givens with the number, unit, and the symbol. Step three, we want to write down our unknowns. What do we not know? And we write it down with the symbol and a question mark. Step four, we are going to pick an equation that will help us solve for the unknown. Step five, we are going to rearrange that equation if we need to, if it's necessary. Step six is we are going to check our units. Super important to make sure that it all works out using the equation from step five. And then step seven, finally, we are going to solve the equation by plugging in the numbers, plugging in our givens. So we reviewed this last time we did problem solving. It's important to remind ourselves about this process before we move forward with Unit 3, problem solving. So let's talk about step four, the equations. What are the equations for this unit? It's been a while since you learned that. So remember average speed. We have an equation for average speed. Remember, speed is represented by an S. The average is represented by a bar. So that's S bar, or average speed. Average speed can be calculated by taking the total distance that is traveled, so D, and dividing it by the total time. So we're going to divide it by T. So that's our average speed. That's how we calculate average speed. Average velocity. Remember, velocity is represented by a V. And in order to represent the average, we're going to write a bar over it. So V bar, or average velocity, can be calculated by taking our total displacement, so our change in x or our delta x, and dividing it by the total time of the motion. So that's our average velocity. Remember that S bar stands for average speed, D stands for distance, and T stands for time. And then V bar stands for average velocity, delta X is displacement, and T is time again. So we do have another small equation to help us calculate displacement. What is that equation? Displacement is the change in X, or our change in position. That's our definition. So how do we calculate our delta X, our change in position? Remember, delta means change. If we're calculating the change, that means we're going to take our final minus initial. So our final position and subtract our initial position, or our X final minus our X initial. Okay, final position minus initial position. That's what displacement is. Doesn't matter what happens in between, but that's displacement. All right, here's our example one. Miss Nielsen's pacing in her classroom. She walks 5 meters to the right, turns around and walks 3 meters to the left, and then turns around again and walks 0.5 meters to the right. What is Miss Nielsen's total displacement traveled? Total distance traveled and her displacement. I kind of combined those two. Remember, our first step is to draw a picture, and that's going to be really important in these problems. So I'm just going to draw myself a little number line, because I'm just walking back and forth left to right. I'm going to make some meter markings here, so each of those markings represent 1 meter. And I'm going to say that my 0 point, or wherever I start, is like right there. And that's a really easy thing for me to do. It's just like, if it's not specified in the problem where the person starts, go ahead and just put them at the origin. Put them at the 0 point. So I'm going to start my walking at 0. I'm going to say I start at 0. It doesn't say where I start, so that's the easiest point for me to put. Then it says I walk 5 meters to the right. So that would be from 0 to then 5 meters based on my scaling of my drawing. So I end right there at 5 meters, right? I walk 5 meters to the right, it says in the problem. Then I turn around and walk 3 meters to the left. So if I'm at 5 meters and I walk 3 meters to the left, I'm going to be then at, 1, 2, 3. I'm going to be at 2 meters. So and then I'm at 2 meters. And then I turn around again and walk 0.75 meters to the right. So I'm at 2 meters, and I'm going to move 3/4 of a meter, so I would be right there, not quite at 3. And what is that point? That point is, well, 2 meters plus 0.75 is going to be 2.75 meters. Now I just got that from my drawing. So I got a lot of information from my drawing. So what am I given really? Well, I told myself that I was starting at 0, which means my initial position is 0. I just decided that because it's easy to say you start at 0. Then I figured out from my drawing that my final position was at 2.75 meters. So that's going to be really handy, these two facts as we are trying to solve this problem. So those are the two things I'm given, along with all of the different steps to get to those places. So what am I trying to find? I'm trying to find distance, total distance traveled, so that means D is equal to question mark. And I'm also trying to find the displacement, so delta x is equal to a question mark as well. So those are the two unknowns for the problem. How am I going to solve for them? Well, I have my displacement equation up there in the top right, so I'm going to copy that down. My displacement, or delta x, is equal to the final position minus the initial position, but we don't really have an equation for distance, and you'll see why here when we move on to the next step. We don't need step 5 because we don't have to rearrange anything. We're solving for delta x. But when we think about step 6 with our units, well, delta x and our positions all have meters. So the only unit given in the problem is meters. So our displacement is measured in meters, our position is measured in meters. Meters minus meters is just meters. So we're good there. We know it's all going to work out. So finally, let's solve. Let's solve for distance first. So distance is just the total ground that's covered. So all of these distances that I'm walking, 5 meters, 3 meters, 0.75 meters, I'm just going to add them up because again, the direction doesn't matter. Distance is just a scalar. So I'm going to add up 5 plus 3 is 8 plus that 0.75 meters is 8.75 meters. That's my distance. Again, it doesn't matter the direction, I just added up those amounts. So then if I want to find my displacement, I just have to take my final position, which I got from my picture, was 2.75 meters, and I'm going to subtract my initial position, which was 0, because again, I just decided that I was going to start at the origin to make my life easier. So that means my displacement, or my delta x, is 2.75 meters. So that's how much my position changed from start to end, but overall the total distance, or the ground that I covered, was 8.75 meters. Okay, so that's a little bit about distance and displacement. Again, displacement only cares about where you start versus where you end, but distance cares about all that happens in between, how much ground do you cover. So here's example number 2. Mr. Willauer takes his lunch break at Olbrich Park. He travels 3.1 miles south to Qdoba, which takes 6 minutes. Then he drives 1.7 miles north to MGHS, which takes 4 minutes. What is Mr. Willauer's average speed and average velocity? So again, we're going to start with a picture. I'm going to say, hey, that's Olbrich. Then we drive 3.1 miles south to Qdoba. So I oriented it like a map, driving down, driving south. And then he drives 1.7 miles north to MGHS. So like I did in the last problem, it's going to be helpful if I know like where MGHS is located in reference to Olbrich, because again, final position minus initial position. So let's say I'm going to make Olbrich my 0 point. That's going to be my origin. Then MGHS is located, well, if I take 3.1 and I subtract 1.7, a little bit of geometry there, MGHS must be 1.4 meters south. Another way I could write that would be negative 1.4 meters, right? Because south is a negative direction. And I just got that from subtracting those two distances I was given. So I am given 2 different things in the problem. So the total distance or the total ground that Mr. Willauer covers is just the addition of those 2 distances. So he covers a total ground of 4.8 miles. 3.1 plus 1.7 miles. And then I also know the total time. So this is kind of a new thing. Our total time is 10 minutes because those time values in my equations are the total time, not individual times. It's total time. So he spends 10 minutes on this journey. Okay. I also know my displacement, right? I know where he starts versus where he ends. So his final position is 1.4 meters south of his original position, which, like I said before, is like negative 1.4 meters, or 1.4 meters south. I'm going to plug the negative in there because it's easy when I plug into my equations. We know south is a negative direction. Okay, so that's why that negative is there. He ends 1.4 meters below where he started, so negative. What am I looking for? Well, I'm looking for average speed, that's what they want me to find, and the average velocity, so S bar and V bar. Okay, so next step is number 4. Pick an equation. Well, I'm going to use the 2 different equations here for average speed and average velocity that are given to me. So average speed is equal to the total distance divided by the total time. And then average velocity is equal to the displacement divided by the total time. Again, just copy those equations. I don't need step number 5 because I'm looking for speed and velocity, and that's what those equations are solved for. So step 6, I'm going to check my units. Speed and velocity have the same units, so I'm just going to check the units for one of these equations because I know it's going to work for both. So in the problem, I have to look at what are my units for distance and what are my units for time. So I'm given miles for distance, right? 3.1 miles, 1.7 miles, and then my time is given to me in minutes. So even though our traditional unit for speed is meters per second in physics, that doesn't mean it can't be anything else. So as long as it's a distance unit divided by a time unit, so miles per minute, kilometers per hour, meters per second, whatever it is, that's good. So my units check out, I get miles per minute. That is a distance versus a time, okay? So now let's solve. I'm going to plug in my distance, which I calculated was 4.8 miles. That was the total ground that he covered, 3.1 miles, then 1.7 miles. And divided by his total time of his journey, which was 10 minutes. So if I plug that into my calculator, I get for my average speed, Mr. Willauer's average speed is 0.48 miles per minute. And remember, speed is a scalar, so it doesn't need a direction. Okay? But now it's time to calculate average velocity. So if I want to calculate average velocity, well, I'm going to take my displacement, which was negative 1.4 miles, because he ended 1.4 miles below where he started. And I'm dividing again by the total time of his journey, which was 10 minutes. Oops, I forgot my average bar there. So my average velocity, again, is negative 0.14 miles per minute. So again, remember this negative tells us that it's in the negative direction. We know he ended up south from where he started. So another way that I could write this velocity as opposed to negative 0.14 miles per minute, I could write it instead as 1.14 miles per minute south. Because again, the negative direction is south in this problem. So I could write it as negative or I could write it as south. I just can't write it as both. So there's my direction, because remember, velocity is a vector. So now it's time for our last example, example number 3. When it's safe to travel again, Ms. Nielsen hopes to take a trip to Italy. On a flight from Chicago to Rome, the aircraft has an average velocity of 614 miles per hour east. If the flight lasts 7.5 hours, what is the displacement of the airplane? So again, starting with a picture that's going to give us some context. We've got Chicago and Rome. Looking at a map, Rome is to the east or to the right of Chicago. So I'm going to make Chicago my origin, and then whatever displacement is in between them, I'm trying to find that. So my picture isn't anything really special in this problem. I'm told in the problem that the average velocity of the airplane is 614 miles per hour east. Again, velocity is a vector, so it has to have direction. So I know that my average velocity is 614 miles per hour, and I'm not going to put east there because east is a positive direction. So I have positive 614 miles per hour. That's my average velocity. I also know in the problem that the flight lasts 7.5 hours. So 7.5 hours, that is a time unit. So that's my time for the problem. So I'm going to write down 7.5 hours is equal to my time. Those are the only two numbers I'm given in the problem. So now I can move on to step 3, my unknowns. I'm asked to find the displacement of the airplane. So it says that right in the question. What's the displacement? So my delta x is equal to question mark. I know my displacement is to the east because of a map. I know that Rome is to the east of Chicago, but I don't know what that displacement is, how far separated they are. So now, number 4, an equation. If I'm trying to find displacement, I might think to use my displacement equation. However, I got to look what I'm given in the problem. I'm given the average velocity and the time. So I'm actually going to use my average velocity equation. So that's going to be the one I choose. So average velocity is equal to the displacement divided by the time. So now I actually do need step 5. I need to rearrange this equation because I'm trying to solve for displacement, which means I got to get it by itself on that side of the equation. How am I going to do that? Well, I'm going to multiply both sides by time. I'm going to get time over to the other side. So that means that my average velocity multiplied by my time, I'm going to use the colors to match up here. So multiplied by the time, that's going to be equal to my displacement because time cancels out on the right side of the equation. So that's my rearranged equation. Now step 6, I want to check my units. So again, we don't have our traditional meters per second in this equation. We have miles per hour for our average velocity. So we've got miles per hour, and our time is given to us in hours, right? We've got 7.5 hours. So miles per hour times hours, that's going to cancel out. So we're left with miles. Miles is a distance unit, so that works for displacement as well. Remember, displacement and distance have the same units. So now it's time for step 7 for solving our rearranged equation from step 5. So we're going to plug in what we know. We know our average velocity is 614 miles per hour, and we're multiplying by that time that we're given in the problem, so 7.5 hours. And that is going to be equal to our displacement, right? That's our equation from step 5. So my displacement, if I plug that into my calculator, I get a displacement of 4,605 miles using my units from step 6, that's miles. And again, this displacement is positive because it's in the positive direction. We know this displacement is facing east, okay? So because Rome is to the east of Chicago. So our displacement is 4,605 miles east. And that's that. So those are our example problems. You'll see some of these problems on the worksheet for today. The most important thing to remember, I would say, is to draw a picture, especially in this unit that we're in, Unit 3. When you draw a picture, you're able to assign an origin, usually where the object starts. That's the easiest thing. And from your picture, you can find the final position, if you can. Like in the example 1, where there were multiple movements in the problem, that's really easy from your picture. You can get a lot of information just from the picture that you draw. It gives you a lot of context, and it's really, really handy. So moving forward, pictures will be a really important step in the problem-solving process. I know last unit we didn't do it as much, but it's going to give us, like I said, a lot of context. So pictures are really important. But that's all for today. Next step is for you to complete the worksheet 3, problem solving.